Now let us see the next form of equation of a line, which is called as normal form. Now in this normal form, let us consider any general line as shown in the figure here. Now let us consider the perpendicular drop from origin to the given line, and let the length of that perpendicular be denoted by p, right? Small p, that's the length. So let us consider maybe m as the foot of the perpendicular. Now if we consider the angle made by that perpendicular segment OM with the positive direction of x-axis as say alpha or theta, any symbol would do for the angle. Now with these two informations, that is, like, we are given what is the length of perpendicular from origin to the line and what is the angle that which perpendicular makes, what will be the equation of the required line. Now here let us do a small construction just for the sake of convenience. So if we drop a perpendicular from M to the x-axis, so that is Mn, now you see that the segment OM makes angle alpha with positive x-axis. So therefore clearly the coordinates of point M can be written as P cos alpha and P sin alpha, simply because cos is the x coordinate, the cos component is x coordinate, and sine component is nothing but on the y coordinate. So we get the coordinates of point M. Now additionally, of course, we know that origin is nothing but 0, 0. So therefore can't we calculate slope of the line OM, right? That we use the formula for y1 minus y2 upon x1 minus x2. So the difference of y coordinates, which is p sin alpha minus 0 upon p cos alpha minus 0, right? So that clearly gives us the slope as tan alpha. So that means slope of the perpendicular segment from origin to the line is tan alpha. So therefore slope of the line, we have seen the result earlier that if two lines are perpendicular, then slope of one of those lines is negative reciprocal of the slope of the other. So here we get slope of the line as minus 1 upon slope of OM, that is nothing but tan alpha. So minus 1 upon tan alpha is nothing but minus cot alpha, also we can write in different way. So that means we have got the slope of the required line, that is minus cot alpha, and we also know one point that lies on the line, which is point M. So now using the slope point form, because we know the slope and one point, we can easily write the equation of the line as y minus y1, that is y minus sin alpha, is equal to m into, that is m is nothing but minus cot alpha, into x minus x1, so that is x minus p into cos alpha. So on simplifying this particular equation, we get the final form as x cos alpha plus y sin alpha is equal to the perpendicular distance of the line from origin, which is p. So this is what we call as the normal form of equation of the line, right? Let's go ahead and see another form, which is called as the parametric form. Now again, this is almost the same thing but with little different terminologies. Now here what we have is like one point that lies on the line. So let's call that point as say x1 comma y1, right? Now let's consider a general point on the line, that is x comma y. Now we know that the line will always have some inclination, let's call it as theta, and from these 2 points once again drop the perpendiculars on x-axis, and from the given point we drop the perpendicular on the other vertical line, right? So as we have seen, this is x minus x1 and the vertical difference is y minus y1, and the theta is the same because the lines are parallel. So therefore we can write here cos theta as x minus x1 upon, if you look at this particular triangle, and let us consider that the distance between any general point and the given point is say r, then we can write cos theta as nothing but x minus x1 upon r, whatever is the hypotenuse of that triangle. And similarly we can write sin theta as nothing but y minus y1 upon r. So what it means is we can write r as x minus x1 upon cos theta, and from the second equation also we can write r as y minus y1 upon sin theta. So therefore merging these two we can eliminate theta, and we can just say that we always have x minus x1 upon cos theta is equal to y minus y1 upon sin theta. That is called as the parametric form of equation of the line, and of course that is, we know that that is equal to the distance between that specific point and the general point x, y that we are talking about.